Hello, this video will look at the families of quadratic polynomial functions. Quite a long title name, but really what it is we have several different ways of representing quadratics, and a quadratic can belong to a family of other quadratics where it could be written in a very similar form, and then just by changing a few what we call parameters, which are a, b, and c in this case when we write it in a standard polynomial form, or we could change quadratic could be part of this turning point family where it's written as a, h, and k instead. If I get interrupted because my kitten is trying to play with my pen. That's Maple. So that's what we're looking at. Yes. Sorry. Let me rephrase. We have several different ways of representing quadratic functions. We're going to look at the different ways and when best to use them if we're given some form of data about the quadratic and we want to find the equation. That's our goal today. We went through this example in class, so I'm going to skip through this. But the idea is that in this case, we're told the form of the equation. We're told it belongs to the family, which could be considered written as y equals ax squared plus c, where r, a, and c are parameters that we could vary that will change the quadratic in some way. It might move it up and down, and as we change c, we change a, and it might stretch it out, might stretch it vertically. All sorts of things might happen. It might flip it if we make it. And we're told that it consists of the points 1, 1. It goes through the points 1, 1 and 2, 5. The process with this is you sub each of these points into the equation and you end up with two equations. Just really quickly, the first one you end up with -1 equals a1 squared plus c, so you get -1 equals a plus c. Sub in the second point, you get 5 equals a2 squared plus c, we get 5 equals 4a plus c. We have two equations with two unknowns in them. We could solve this using simultaneous equation. Right. Let's get on to the main nuts and bolts of this lesson. We've seen so far three different ways we can write quadratic functions. We'll start with number 3 and actually work backwards, is we have the standard polynomial. Y equals ax squared plus bx plus c. Quadratic polynomial. We then have the form that we get to when we're about halfway through doing the completing the square factorization method. It's when we've added and subtracted what we call our magic number, and the perfect square from the first three terms have been collapsed to this square, and then we also have some plus or minus constant out at the end, which we call now turning point form. And I'll get to why that's called turning point in a second. And then we have also our other really familiar one when we've fully factorized it, and we have x minus something in brackets x minus, or x plus something in brackets, and again. And we know that those two, using the null factor law, E and F become our x intercepts. So of course we call this the intercept form. Polynomial, it's the most general. You use this third form when you're given three random points, okay, that aren't really special. Okay, they might be, they aren't intercepts, they aren't turning points. If you're given just three random data points or coordinates, you would use the polynomial form. This turning point form, okay, it's called turning point form because the turning point of the quadratic, when written like this, is at h, k. That's its x value and that's its y value. Or using our TPx, TPy notation that we've had in class, we could say our turning point x coordinate is at h and our turning point y coordinate. So that's why we call it turning point form, because once you've got into that, it all turns out that always the turning point exists at whatever number h is, whatever number k is. And so we would use that, if you're told information about the turning point, if you see where it is, or you're told the coordinate of the turning point exists, we can substitute that information in for h and k, and then we could use information about some other coordinate to figure out what A is. And then finally, our intercept form we use if we're told information about the intercepts. If we're told what the two x values of the intercepts are, we can substitute that information in for E and F, and then we can use the one other point. Both these cases have one other point. We use that one other point to figure out what A is. Again, by substituting that point in for X and Y, solving for A, we end up finding what A. Again, thinking that the whole purpose of this exercise is to find the equation of the line when you know what points it goes through. So, let's have a quick look at this example. We are told a parabola has x-axis intercepts of -2 and 6. X equals -2 and x equals 6 as our intercepts, and then passes through the point 1, -30. Well, which of those three representations would be best to try and use to figure out what the equation of it is? We're given intercepts, we want to use the intercept. So we could say it's y is equal to x minus e, x minus f. And it's always negative signs in there when we've got intercept form. Now we can substitute in our two intercepts for E and F. So we get y equals a x minus, and we put them in. So I'm going to put -2 in there, and I'm going to put 6 in there. And simplify it a little bit because of the double negative sign there, or the subtracting a negative. It becomes ax plus 2 bracket x minus 6. And we're 95% of the way there. All we've got left to figure out is A. So from here, we just need to substitute in our other data point. Like I said, we're going to substitute in our other data point as x and y, and that will allow us to figure out what A is. So we sub in 1, -30, and yeah, -30 is equal to A. Subbing for x is 1, 2, bracket 1 minus 6. We get -30 is equal to A, 3, not comma brackets. -30 is equal to -15A. So A will be -30. 15 is equal to 2. So we can say at the end, these three little dot symbols means therefore y is equal to 2 bracket x plus 2 x minus 6. So that's using some information we're given and knowing we can write quadratics a certain way, patterns that they have, we can figure out what the equation is. This next example, the coordinates of the turning point of the parabola are -2, 4, and the parabola passes through 3, -46. -2, 4, and red, and 3, -46. Now, this is our turning point. That's the turning point of the parabola at -2, 4. So we know our turning point x coordinate, -2, our turning point y coordinate is equal to 4. And if we go back and look at this, I said that the turning point x coordinate we can always substitute in for h, and the turning point y coordinate we can always substitute in for k. So, y equals a bracket x minus h all squared plus k is the turning point form. And we know that turning point x is equal to h, turning point y is equal to k. Again, in this one, we have to be careful with the sign in the standard form. This is a negative in here. We're still substituting whatever the number is in for h, but we need to know that it starts as x minus h. So we get y equals a x minus, substituting our h value, which in this case was -2, all squared plus sub in our turning point y, which is k. Simplify this down a little bit, so we get y equals x plus 2 all squared plus 4. Finally, as we said before, we can substitute in this bit of information for x and y, find a. So we're going to sub it in 3, negative 46. Negative 46 is equal to a. 3 plus 2 is 4. Negative 6 is equal to 25a plus 4. Take 4 over, we get negative 50 is equal to 25a, so a is equal to negative 55, which is equal to negative 2. Therefore, we can finally say, figured out what our a is, we already substituted in our h and k, we know that the quadratic equation is now y equals negative 2 x plus 2 all squared plus 4. That's a review of some of what we did in class today. Hope that helps. I know everyone was able to copy down the notes for this third example, which is quite longer. It's that more involved one where since we're just given 3 random points, this first point isn't special, this third point isn't special, this point is a y-intercept, it's not an x-intercept, so we can't use it in intercept form because the intercept form is just for x-intercepts. So we just have to consider it as another random point. 3 random points, so we would just substitute all 3 of them into y equals ax squared plus bx plus c, and then you have a triple simultaneous equation. This y-intercept's really nice though, because it turns out straight away that you get negative 3 is equal to c, so you get the c straight off the bat, sub that in, then you're down to a double simultaneous equation. I will leave it there. I hope this helps.